Okay, I thought I would help you guys out. So we're going to find the derivative of y with respect to x. We're looking for, you can write y prime or you can write dy dx. You should realize, well, this has got to be implicit differentiation. I don't want to solve for y. And so we're going to take the derivative of this piece, but you're going to have to use a product rule. You're going to take the derivative of this piece with another product rule, but my derivative of 6 with respect to x, that's going to be easy. That's 0. So let's see, my first function, because I'm going to do the product rule, the first times the derivative of the second function plus the second function times the derivative of the first. So that's first function, the derivative of the second function, I'll call y prime, plus the second function y, times the derivative of the first function, the derivative of x squared is 2x. And so I want to show, hey, that's the derivative of my first piece, x squared y, so I'm going to put it in brackets, okay? So now the derivative of xy squared, that's going to be, again, product rule. X, my first function, the derivative of my second function, a little more complicated, so the derivative of something squared is 2 times that something to the first power. But y refers to some other function. Y refers to, like, the function if you solve this y equals. So I have that function squared, so it's going to be the derivative of y squared is 2y, chain rule, times y prime. Plus my second function, y squared, times the derivative of my first function. Well, the derivative of x with respect to x is 1. The derivative of 6 is 0. Okay. You don't really need these brackets, but I think it helps. Most of you are probably writing kind of like this, so you have a bunch of parentheses, so the brackets just kind of help you out deciding this giant piece is the derivative of x squared y, and this piece here is the derivative of xy squared. So I'm expecting, oh crap, I already realized I made a mistake. I shouldn't be saying y prime, I should be saying dy dx. I'll fix that at the end. So I have a y prime here, I have a y prime there. I expect my derivative to just say y prime equals. So I'm going to do some algebra. So let's see, I have x squared y prime plus 2xy, that doesn't have a y prime, plus 2xy prime, that's a lot, plus y squared. So I'm going to move everything that doesn't have a y prime to the right hand side, and I'm going to have x squared y prime plus 2xy prime is equal to, I'm going to subtract 2xy from both sides, and I'm going to subtract y squared from both sides. So I still don't have y prime by itself, so I'll factor out y prime. And I'm going to have x squared plus 2xy left over. And I'm just going to divide both sides, so I'm going to have y prime is negative 2xy minus y squared over x squared plus 2xy. And then, like I said, I already made a mistake. I don't want to go back and re-record. So we're going to say y prime equals dy dx. And so dy dx is equal to negative 2xy minus y squared over x squared plus 2xy.